вчерашнего ужина, надеюсь, никто не думает о втором таком же, начиная с утра. Вот. Если что-то не успею рассказать, ну, можете скачать презентацию, можете посмотреть сразу, чтобы четко было понятно, на кого направлен доклад. Кто подошел новый, год тому назад, ничего. А Postgres я слышал там 5 лет тому назад, у нас была проблема, что нужно думать о SQL, и примерно вот в прошлом году мы об этом задумались конкретно, потому что наше правительство сказало, что SQL, оно должно быть, я считаю, это правильно. Проблема в другом, очень быстро. Вот.
Because we said that experts need to think, really cool experts. We need to improve our own competences. We shall not borrow them from somewhere abroad. The report and the presentation is as follows. Last year, I wanted to find out what shall I do with my system. In what way shall I write the code? Shall I do something about the system? Shall I think about something? We were thinking over about this, we were writing about this, and all of a sudden, I say it all the time. I often forget about this, and we change the situation, change the system, and all of a sudden we face again the same problems because we have forgotten about them. The most important thing, what you shall think about and in what way shall you start. You have code, we have information. You can always download information in the internet, and this is the correct approach. However, the problem is we don't know what keywords to use in order to find the right documentation in order for us to write the right code. Those who do not Postgres, probably, I think people will not be interested if you know Postgres good enough. But when you learn and when you get the information about the SQL service, SQL syntax, then probably it will not be that interesting for you. My name is Yury. My colleague is here with us. We have a company that's been developing specific pieces of software for over 25 years. We do everything for what the customer is ready to pay. And I'm sure we are producing some fine pieces of software. We have departments of our company that provide standalone software. Some of our company departments provide solutions and hardware. We optimize our software rate. It demonstrates even higher productivity and performance as compared to hardware IBM rate. And at the moment, I'm busy with the document flow. It's like DocsVision. This is a platform to develop various solutions for electronic document processing and document flow. For state organizations and enterprises, we have specific Russian solutions. The reason is our governmental authorities have specific requirements. That is why we adjust and fine-tune these specific pieces of solutions, because our Russian companies, they want the SPL. Here are the list of our customers. You can see a lot of state authorities and state enterprises. They are large commercial enterprises, Sberbank, for instance. Our system is the most productive one. You will not find any other system on our market that will be able to offer you a higher productivity, higher performance and stability. And at the moment, 50,000 people are able to work in the system simultaneously. Some of you may think that the digit is small enough. But if you think about the essence of document flow, it's a diverse data set that shall be put together when every single user accesses it. So this is our company, and it's like a set of different departments, divisions. There is a brief slide demonstrating what the product is. We have database, we have cluster of application. We have a central node. This is database. We have business server cluster. And actually, you can have an unlimited number of servers accessing the database. We also have a client here at the layer of business application, and we used to have access to the database. Previously, we worked with the commercial SQL Server database, but unfortunately, you can see the pluses here, everything was a bit mixed. We used to have a very complicated data, request generators, metadata, descriptors. Everything was mixed together because at that time we didn't expect to have such a complicated system. So here we have a database. It has a specific set of objects. We have static generated objects. They are included into meta description, that is the XML descriptor, stating that there are some interdependencies, indexes, fields, everything is stored inside the platform. But we also have the extension capabilities that enable us to extend the capabilities of this database. There are some examples when, let's say, one C company and wants a product, they provide these extensions based on our platform to provide additional features and additional functionality. There are some integrated objects that are related to the database. We have specific search mechanisms. Please don't mix them up with the SQL search capabilities and agents. This is a complicated mechanism, a technique that tracks all the discrete security measures and processes and launches different processes and operations. We have display mechanisms. Once we found the data, we need to display this data. You may think that is extremely simple, so you just demonstrate the data the way the user wants. That means it's a very complicated display system. Let's say a search system. You may have 10 procedure calls in a row. And here we can inject some business applications that will verify security, that would verify the procedure operation. The logics is extremely complicated. And every time I say search, it's not an SQL search, but it's a much more complicated mechanism. And now, where do we have the SQL? In any standard application, and whenever we have over 100 lines of code, we need to use the SQL. We have meta description. This is the description of the objects that are to be included. There is a description of the objects that may be loaded. Based on these descriptors, we generate the database. As the time goes, we increase the volume of the database. Some developers may add additional extensions, additional elements, additional tables, and based on the table and business logics, we get the appropriate database. The system also has SQL code and also prototypes. Prototypes is a set of extensions. It's like when you have SQL code and within the code lines you have some templates that may be replaced during the generation time, and these templates are replaced with the real working SQL code. When installing, we have to think about the system update, because during the update and upgrade, we need to verify all the tables, all the headers, we need to verify data typization, we need to verify all the fields, all the interdependencies, and the logics is extremely complicated. We want to go through all the typization, all the objects, all the dependencies. But the thing is, during the operation, the system generates objects to access the data. This means that during the update, we need to either remove these objects or we need to isolate it. When we generate a code to be updated, it usually means 1.5 million SQL code lines. This number of lines later on is applied to the database. And now about the specifics. So, why it is so difficult to interact with the database? Usually, we operate standard DBMS system access codes and requests. And I say that in order to get a good system, you need to implement business logics. You need to understand the data at the business level. You need to understand the business value of every single object within the database. And all the data shall be in the highest priority as compared to the in-system logics. And all the logics goes through this storage system. And it took us a lot of time to realize this very thing, because we had to understand in what way to interact with Postgres in order to optimize all the mechanisms and operations. We, for example, had to call several procedures one after the other. We need to think about the security of the lines to be displayed, and we need to update and make changes to the database and to the software server. Very often we get some problems and some challenges at the implementation stage. We also have the RLS system that is implemented at the security descriptor level that exists at the line level, but not at the software server or app server. Sometimes we have different security requirements. For example, it's like, similar to Windows operating system, you may apply specific security restrictions to every specific file. You can do exactly the same using our solutions. Plus, in addition, we add up additional business models or business role models, because we need to understand the access rights based on your business role, but not based on your user role. We had to switch into SPO. Vladimir Putin said that tomorrow, that was said about 1.5 years ago, he said that everything is okay, we shall not use any foreign or external system. That is the basic requirements, and he said to do that by June. Gasul is absolutely everything for us, the same thing for them. It's absolutely clear that we used to think, so what system to choose? Frankly speaking, we didn't have a lot of options to choose from, but we had to have a certified security system, and this is the only system we have, that is Postgres Pro. We selected Postgres. Secondly, we decided to go for Linux. Moreover, we listen to different reports. Postgres supports compilations. For instance, we lack specific feature, so we can develop it, then we can compile and integrate. This doesn't work for us because of two reasons. First of all, we can take the responsibility and change the errors, but the problem is certification. This shall be certified. If you want to use DBMS, you need to be certified. Everything the DBMS provides, everything you can get from it shall be certified. Because we have a very nice developer who can develop absolutely anything at any time in any situation. It may be a standard solution, you may deploy and implement it. And for example, our customers, they really enjoy Windows and Linux. But once they have made their final decision, we shall be ready to implement any solution in any environment. For example, if they want to switch to Linux, so we switch to Postgres. This is an absolutely independent configuration that can accommodate any type of environment. We use the booknet and we also use the SQL server. But when we face that, we were terrified. What shall we do? Because in order to change the code, code change would require 15 years. So we gathered together, we thought over the situation, and then we decided, so we have a lot of interesting things to do. For example, that was the reason, that was the time when we sat down all together, and I would like to mention once again, the system is terrifically complicated, and we managed to implement that over a 9-month period of time. Me and Volodya, he dealt with app servers, he also works with Postgres and SQL code. So we spent 10 people month. So, and 9 months for Linux. So as for the Linux, this was not, so the most consuming point of time was related not to a significant change, but we just decided to use a .NET Core that was compatible with Windows and Linux, because the task was, we have a code and it shall operate in any operating system. That's why we could not afford supporting different options and different variants of code. That means that the code shall work pretty fine both in Windows and Linux. We spent about 15 years writing the code. We looked at it, we made some changes, and we found a nice solution. We decided to extract files because the files used to be stored in the SQL server. But we decided to implement a different storage system, and in order not to store the files in the Postgres, we decided to store in external database. This external storage may be the database. We differentiated the data layers because we wanted to leave the app server alone, because we checked that these app servers compile the codes, it works fine, and we selected a separate software layer with a generator with access, and we actually implemented the inherited elements at the level of every single access to the database, that is SQL and Postgres. Every single platform has several DBMS. Everything related to cloud transactions were separated and split into operations. We have the data generation and display at the DB level. So we decided to separate all these procedures from one another in order to avoid different incompatibilities. That means that in case we experience any type of incompatibility, we rewrite the specific part. And I will go more further. My presentation actually is about what I would like to hear when we start developing something. Here are actually two things we need to think. There are just system-level elements. These elements do not affect the code. This is exactly what you have to keep in mind when writing or rewriting the code. System thing. Security. SQL Server has two-level security. There is SQL Server authorization and database authorization. These are the two elements you need to take into account when moving to a new system or database. Postgres has one-level authorization. You have the authorization of the database. And SQL is like a database container that were introduced recently. So the security is specified at the database level. And I'll repeat myself again. For those who write the SQL server, when you switch from SQL to Postgres, you face the problem that you do not understand the type of life or lifestyle you got used to. You need to think about the SQL server. For instance, when you work in Windows, you have the domain authorization, but in Postgres, it's a pseudo or so-called virtual domain authorization. It means that this security level is weaker, but at the level of Postgres, we shall define the security level at the protocol level. It actually stipulates what IP addresses would be authorized to access database or not. In Postgres, the authorization is more strict. You can specify all specific nuances and all details, because you may stipulate that this server will have access and this will not. You cannot do that in MS SQL. Ideology. So, the physical storage and logical storage. SQL is the thing that inside the MSDS, DBMS, you have different databases. There is a database, it's abstract, it has its own object within itself, and you relate specific files storing the data. And it means that several tables may be stored in one file. In Postgres, in Oracle, you have a very specific understanding of the database itself. Database meaning is close to the server. It's extremely difficult to separate database from the server. Physical storage is related to the server. We identify the storage area at the server level, and of course all the tables are stored within every single file, but the description goes at the server level but not at the DB level. In SQL's case, we store it at the DB level. In Postgres, it is less autonomous. In Postgres, the DB meaning is close to the server meaning, and you cannot separate these two meanings, these two notions. But in SQL, you have the transaction logs, you have the WAL relate to servers, and it's common for everything. But in SQL, WAL logs is actually relate to the database. Reasons. We had a few databases specifically optimized to load the database because we have different solutions from the server operating point of view. It's like a complete or full-scale operation when you store all transaction logs, and it's the base itself in SQL. So this affects the performance of database, the operation speed and everything, and within every single database you actually set the operation criterion settings. In Postgres you have some other type and some other approach, and actually you do not have this ability, or you don't have to specify every single configuration within every single database. What else? So here another important thing is SQL Server is not a relative database. That means that you have the specific requirements. In Postgres, the database itself is vacuum. All the data is stored at the level of page data. In SQL, the SQL rewrites every single page on top. And in order to do the vacuum process, and for instance, those who used to work in SQL, they do not know about this because SQL Server does not have this capability and feature. You need to change your way of thinking in order to understand the way Postgres works.
So what else we've got? We had a very interesting discussion with Postgres Pro guys. You can run Postgres on different systems, and there are two types of operating: for minimum and for maximum usage of resources. Postgres is aimed at maximum usage of resources, and I'm hoping that this approach will be changed, because if you call it enterprise version, you can't install this on slow machines, because if you buy expensive support and if you want to have a decent system, you need to have a good machine. Otherwise you can install just a generic Postgres. Also, in SQL there are two settings for memory usage, and in Postgres it's a little bit different. and memory manageability in Postgres is much more flexible. You can allocate resources for plans, for cache, so it's very good in terms of manageability, and it is implemented very effectively in Postgres, but not in MS SQL. Now about code. So we skip that moment, and now let's talk about collation. It is related to sorting, coding and comparisons. There is very important difference, which is called case insensitive and case sensitive. So collation defines how data are sorted, whether they are matchable or not, etc., etc. This difference is very significant. And case sensitive is a very big difference between Postgres and SQL. In SQL, collation affects how system data are stored, how they are compared. You can define your own collation in each table if you want to. In Postgres, everything is case sensitive from the beginning, so it influences on the object. It doesn't affect object naming. So you need to have special operators that show that we are not looking for case-sensitive data. Fast search is defined by index capabilities. In Postgres, you need return indexes to do so. So I'm telling this because we have auto-generator. It's not like I write it in one place and then create index. I have 10 fields, and I would like to have limits for uniqueness and so on, and then platform implements it for you. So sometimes it can be implemented on index level, and we need to think about it in terms of indexes. And we have improved these indexes for comparison. Also, we have CI text to look for case insensitive. You can use these approaches. So we have I like in Postgres, but it cannot use indexes, so fast search is not available in that case. So we can use CI text extension that can perform search for equal, or using patterns for texts. So it's a very specific search criteria that allows you to perform this lookup very efficiently. And I hope that our colleagues from Postgres Pro will help us to improve this process even more. Naming limitations. When you migrate, you don't pay enough attention to this, but you need to think in terms of length limitation. In MS SQL, we have limits for 256 chars, and in Postgres we have only 64 chars. So sometimes we are running out of limits, and what can we do in that case? Well, actually nothing. So we're looking for enterprise professional capabilities, but still this should be implemented on generic Postgres as well. We have verified our code, we have our data layers separated, and that's why it is implemented in different ways. If we're talking about indexes, we can form an object, and then naming, and it might be interesting for you, is defined by hash. So we have a mask for object forming. And if we run out of limits, we can use hash, and then we form indexes using our mask. In SQL Server, we have only bit-tree indexes. We have hash in memory. Postgres has much more flexible system to work with indexes, but when you switch to Postgres, you usually use bit-tree indexes only. And cluster X that describes how data are stored inside the page is not described very well for Postgres. Is there a question? There is a cluster, which means we can clusterize, but there are no clusterized indexes, so we can't define data storage online. Okay, we said let's clusterize it, but it's not an online index. In SQL, it is done on the page level. In Postgres, we know where we got it because it is a versioned data storage. When you migrate to Postgres, you understand that you don't have clusterized indexes, but we have functional indexes instead, and they are related to data types we're going to talk about a little bit later. What about typization? There are several data types, and Postgres and SQL are very good in terms of data types, but first thing is the bit mask. For Boolean in SQL is just one bit. In Postgres it's Boolean, very good type, true type. You can easily compare it, but this 0 and 1 they're not matchable. And we had to check these true and false and to match them, or just to exclude these comparisons. So we decided if Boolean is described, we need to use it. It was challenging for us, but still we decided to do so. Timestamp type. Don't confuse it with the timestamp in Postgres and other DBMS, because in SQL, timestamp is a transparent counter. If you have a column in a table called timestamp, it is a changes counter. If something changes, the counter changes as well. But date and time information is not stored in this column, and you don't have it in Postgres. So a lot of people are confusing timestamp in SQL and Postgres. But you should know that this is just a transaction counter. In Postgres, this counter is 32-bit. In order to implement it, we decided to do it on the sequence level. Everything is standardized on the level of all tables, and we have defined that this is a begin table. We have a trigger that just changes your data. Also, we have system function inside the system that shows you the number of transactions. And we're using the same function that just returns the data of transaction changes. In SQL Server, we can track it on the row level. Here we can see only group changes, but that's enough for us. We just need to know what changed inside the database. So this approach is decent for us. Auto counters. You might have faced two moments. First, you connect auto counter, and how can we work with it? We have the same object in Postgres. It came from a long time ago. We had only one counter. It was a specific thing of Postgres, and we are going from typization of generators inside the field. In Postgres it is a type, small serial or big serial. So we had problems with the auto-generation of code. In SQL Server we have a specific function to get last inserted row. In Postgres we have very convenient function that actually allows you to get the return result. The same stuff for GUID. We have unique identifiers for it to track down unique changes. In Postgres we have new GUID, sequential GUID. In order to get them, in SQL Server you can use Alt operator. It is very difficult sometimes to use it, but still. In Postgres you need to use special extensions to do so. We also thought in terms of text. We have implemented very strict matches. We understand that we have a text definition, we have chars, varchars, we have the same characters and types in Postgres. Text is an obsolete type in SQL, but in Postgres text doesn't have any limitations, and we have decided that it doesn't make any sense to use varchars, because from the very beginning they look to the migration length. So we decided that varchar has a fixed length of fields. In SQL, these limitations is the information that is stored inside the page. When you substitute a row, you actually find yourself on the same row. And if the length doesn't change, we actually stay within the limitations of that row. And we have limitations that restricts only the length. But this is the extra load on Postgres, and everything should be done on the application server side. After some considerations, we have decided that all typizations should be thrown away. So, a little bit later, okay? So if we think about specific user types, we should ask ourselves why. Okay, if we're talking about relational databases, they are connected to one thing: how to store data and how to find data. It is related to indexes. we will have another type not supported in Postgres, but we implemented this support. I will tell you how. But let me finish first. Concatenation of rows is a little bit different in SQL and Postgres because spaces are ignored. In SQL, in Postgres they are ignored when you write your code. Just take this into account. Also, another moment, concatenation operation. As long we are using generators and we use only plus operator. In Postgres it is 2 vertical lines. So we rewrite our code and then we understood that we were having problems with the concatenation on the level of specific mechanism. So we decided just to redefine concatenation operator and substituted plus with the 2 vertical lines. It helped us to avoid problems with recoding. SQL variant. This is another custom type as well. We don't have SQL variant in Postgres. We took our time to think how to implement it. Yes, you can have your own extension or your own custom type, but it influences on 2 moments. Not only how to store data, but also how to find data and extract them. So when we are talking in terms of a standard provider, so how to extract this data type and provide it to the application, how to display it inside our fetch, and how to perform search for it. We have found several options, but we decided to stay with the custom type. It's not very good indeed, because they are all stored in one field, and this is EXA storage load. But at least it helps you to standardize the call mechanism. And some of this mechanism can be implemented by types conversion and lookup. In SQL Server it is supported on the provider level and you can search for anything. In Postgres these are custom types, an array. You can store one option and then search for it, or by using a special type. In Postgres you can see how we did it. For every open connection we map data with their type and then we perform the search. Hints and blocks. We're using them very frequently. Main hint is not a problem, but sometimes we're facing problems with the dirty reading. If you are using SQL Server, there are a lot of arguments over the fact that we would like to have our data clear, we would like to see them true. So it's not a problem to read changing data. But if you read data and they are going to be changed, they are not true. So in that case we need to use hints, and hints are not supported in Postgres. We don't say whether it is okay or not, but we don't have blocking read, and we just discarded all these hints, and that's it.
Temporal tables. So we actively use the temporal tables. We generate it all the time. In SQL Server, you have 2 options and 2 variants of SQL tables. That is the variable tables and the real ones. They are generated in a standalone database. That means they have no effect on the main database. They have their traditionality, their relations. The temporal tables are included into the transaction information. We don't have this in Postgres, and the problem is that temporary tables exist and load the main database. They exist the write-ahead log. For instance, in SQL Server, you can play around with this as you can use a separate way write-ahead log. But in this case, everything stays within the database, and you need to take this into account. We also have different visibility differences. For example, in SQL, the temporary table list is identified by the originator block, but in Postgres it exists till all the time the connection is active. And I would like to tell you to read it once again. And we need to also understand what we can do with these temporary tables. But we wanted to facilitate the jobs. That is why we introduced specific functions that check the existence of the tables, their validity, and remove the tables before the use. In SQL, we have a specific tool to do this, but in order to facilitate and simplify the code, we decided to write specific scripts to check the table existence and remove the inactive tables. The traffic specifics is based on the fact that we have data snapshots stored inside the database during the operation and database utilization. That is, the pages of the data. We need to check specific areas before loading the data. There is an option. We can upload this data onto the app servers, but this will require immense amount of storage volume. This is not rational. That is why we store the data within the database. Such snapshots are not present in the SQL, and all the data, all the tables are locked. In Postgres, we can differentiate specific tables, specific snapshots, thus increasing the performance. Here we are not interested in integrity. We need to know what table relates to what user. We do not care about the integrity or continuity. You can use multiple tables to store the data. Calls to different database. In SQL, everything is done in a very transparent way. If you have the access, you can easily switch to it. In Postgres, we have problems with access to different databases, but there is a solution. We don't have a standard agent. We use the PG agent, and Postgres colleagues are developing their shadower. There is a small API on SQL Server to implement the jobs that are active at the moment. But the specific is, at MS SQL you can use it at any time, but PG agent works in specific periods of time during the day. In order to launch it, we use triggers. You will be able to download this presentation, that's why you will be able to read it. Select. It's quite difficult to make the updates because sometimes we need to have the table in off-roam, you need to rewrite it, and there's just aliasing requirements. In Postgres, this aliasing requirement is much more strict and more important. We don't have a merge operation, but we have a workaround. You can use like tonic operator within the STI expression. So we have no output, but we have the return. This command gives you information about all affected data. In Postgres, you can do it within the internal platform table, and it enables you to select this data. In Postgres has the return command, you select the specific column of the table. What about the output delete? Yeah, it's just returning you can get for various options. Postgres has the same for update, insert, and delete. But if we're talking about the insert, we don't have any access to remote records. Returning gives you all the information about all changed data. Insert, update, delete. The difference is you don't have the previous version for update. trigger is additional code, additional load, and unwanted feature. Attributing value. The only difference in SQL, we attribute select a value. In SQL Server, we do not find the select value. We don't change the value. But in Postgres, we get it null. Moreover, we don't have the concatenation of the lists. We have the array, and we can actually use a different code solution, dynamic scripts. We do experience significant challenges here. It is impossible to transfer the value. This dynamic code may send the data from Postgres, but we have to declare part of the data and predefine the values and the data type. In this very case, everything works predefined, but dynamic scripts experience difficulties with transition of several values. The logic is extremely complicated, and you cannot display the result for a few selects. Storage procedures. So this slide provides a lot of information. In SQL Server, you have just a set of functions and requests that you may use in any way. And in Postgres, these features and comments are pretty much the same. So here, this slide demonstrates the way you can return a lot of data, a lot of results. Here you are talking about business. We want to call back different procedures that are related to business. In Postgres, you will get only one return value, but these parameters enable to give you a variative results for every specific request for every specific business logic. Here, this is the way we do the feature or procedure removal functions. I want to say a lot of things, but unfortunately I'm running out of time, so we have problems in SQL transactioning. In Postgres, we all make all the requests as transaction, and that is it. So we are implementing everything in min.prompt.org on the Ministry of Trade. We're installing everything, we're testing, fine-tuning the system and the future. And the future orders and customers will come from some other state companies. It's a large report. Next time, you need to make a masterclass for 3 hours, and you'll be able to tell, oh, you know, being a tutor, I want just to teach people so they experience less problems. Okay, only one question. Time for one question only. You know, it's scary because there are no questions. Everybody is so scared, or either you understand it too well or you don't understand a thing. Maybe you can take a mic. Hello. Thank you for the presentation. My name is Nikolai. Everything is absolutely clear. Business transition from MS SQL to Postgres, you have the same problems, so actually we try to overcome it. The only thing I cannot agree with, we really enjoyed a strict data typization by defining the users. It helped us a lot. And secondly, it requires a lot of funds and cash in order to rewrite the storage system. Frankly speaking, you don't have to be afraid of this. Everything is done perfectly well without any hassle. And in this slide it says like 25,000 lines of code, and I was the one who rewrote and reworked them. We use generators that make the changes, but the thing is, good developer standardization. So guys, write always the code in such a way that it is easily understood by everyone. As I teach, I understand the SQL. Custom data type is a very exciting thing, and actually you will never need to use it in variative or relational databases, and I'll tell you why. what do we need the data type for? We need it in order to find the data. But if you want to store and if you don't want to search this data, then you shall not take any care about storing these data types. You can select and create a custom index based on the data type. You cannot do that in SQL type database. You can make a very nice data transformation so you can store it the way you want. SQL, what for do you need the data type for? SQL Server is a block. You can describe, you can store, you can redefine. It may be the standard type that is renamed, or it may be a complex type. If we're talking about renaming the type, then it's like, a custom type. It's a standard type. But if we're talking about a structure with this length, it means that we lose the search capability. And if we say that I want to find this object, then we need to compare it with something. But we can compare only blocks. And if you say that the index is not... Well, you do not understand the question. The scalarity synthesization types of data, if you have begin in MS SQL and begin in Postgres, I meant this color type, but not the structural types. Well, let's discuss this after the presentation. I know that I'd like to say once more, when you have a structural type, just think about the JSON. JSON is just when you store, you do the indexes, you do the scholar types, and everything is so fast. And if you're just using generator and synthesization altogether, so you don't need to use it anything else, I can just, tell you about this after the presentation. Okay, thank you very much, Yury. This is a very interesting report and presentation.